and welcome to day 13, so just over halfway of the 24-day extravaganza of physics. And today we've got another particle physics one here. So this is actually about specific charge, okay? So the table contains 5 statements that refer to isotopes and some radium isotopes. So remember, an isotope is the same element, so it has the same amount of protons, but different amount of neutrons. So they've ticked you on here. So you've got radium-223, radium-224, radium-225, radium-226. So the isotope with the smallest mass number is radon-223, because that's the one there. The isotope with the most neutrons in the nucleus, of course, is going to be one of the biggest mass number. Let me see if you can fill in the rest of this here. Just give you a few seconds to have a quick go at that. Okay, so the isotope with the largest specific charge. This is actually one of the most important things that we're going to be dealing with this. So specific charge is the charge divided by the mass of the object. So what's going to happen here, the object with the largest, they're all going to have the same charge of the nucleus. Okay, so it's the nucleus. They're all going to have the same charge of the nucleus because they all have the same amount of protons. But of course, they're all going to have slightly different masses because they have different neutrons in the nucleus. So what's the largest specific charge? So you want the thing with the smallest mass, which is going to be this one here. An isotope decays by beta minus. So it loses a neutron, changes into a proton, okay, to become this. So there's no change in the nucleon number, so that must be radon-225. And an isotope decays by alpha, so loses 4,2. So remember, alpha is 4,2. So becomes 22086. So the only one that could be is this one there. Okay, they are worth 1 mark each. We have a quick look at the mark scheme here. So look at the mark scheme there, and that's worth 4 marks. Okay. So here we've got question B. An atom of one of the radioisotopes is ionized. So that is a charge of plus 0.32 times 10 to the minus 19 coulombs. State what happens in the process of ionizing this radium atom. Okay, so this radium atom is being ionized. It has lost 2 electrons from the outer shell. And I can tell it's lost electrons because it's become more positive. It's only worth 1 mark, this, and as you can see here, mentioning the atom is lost specifically 2 electrons. So it says state, so you have to be specific when you have state questions, okay? The specific charge of this ion formed is 8.57 times 10 to the 5 coulombs per kilo. Deduce which isotope, so which one of these is the actual value here. So we have got specific charge equals the charge over the mass, okay? And we've got this here, so I've got 8.57 times 10 to the 5 equals the charge of the ion. So that's going to be 3.2 times 10 to the minus 19 over the mass. So my mass is going to be 3.2 times 10 to the minus 19 divided by 8.57 times 10 to the 5. And that's going to be 3.73 times 10 to the minus 25 kilograms. Okay, I want to find out which it is. So there's a lot of things you can do, but what I'm going to assume here is I'm going to assume the electrons have a negligible mass. Okay, I'm going to include them. So if I had, currently I've got 88 protons, okay, actually, this is a first year question, you wouldn't get this in the second year, okay. So in total, I have X amounts of nucleons, okay, plus, so I've lost 2 electrons. I would have had 88 if it was stable. So 86 times the mass of an electron, so 9.11 times 10 to the minus 31, okay? And that, of course, equals my total mass. So I'm going to take this value, I'm going to take away 86 times 9.11 times 10 to the minus 31, okay? and I get 3.733 times 10 to the minus 25. So like I said, you can actually ignore the electrons in this because they're so tiny. And then I'm going to work out how many nucleons we've got. So x times by the mass of one nucleon, which is 166 times 10 to the minus 27. So divide that by 1.66 times 10 to the minus 27, and I get an answer of 224.9. So looking at that, so I've got 224.9 nucleons. Looking at my isotope data that I have, it will be between 224 and 225, and it is far, far more likely to be the isotope of radium-225, because in my opinion, if it's got a lot of rounding has gone along here, this is closer to radium-225. So there we go. This is just a question on using specific charge, and have a good day.